Welcome. On this channel, I do unscripted, unedited videos about Linux programming and stuff. If you're new to the channel, you probably want to check out the links in the video description. I kind of went in a circle in the last couple of videos. I'm doing a little prompt engineering to create a single-threaded epoll looping server client toy program to learn from, maybe to use kind of as the basis for the eventual game server code. And a couple videos back, there was what I perceived as a flaw in the result from the prompt. It was not handling a certain error condition, and I wanted to handle it. And I tried to modify the prompt, but that led it down a path where it was producing a bad result. And then I tried to fix it, and I saved it in the wrong place and didn't actually test the fix, and it kind of got messy. But today what I'm going to do is I'm going to go back and look at that working code after we corrected everything and kind of just study it and probably likely ask Gemini to create some educational information for me about epoll a little quicker than trying to dig it up on the internet, I think, in this particular case. So let's jump over to the code. Now, this is going to seem maybe a bit unintuitive, but if you go back and watch the previous videos, you'll understand. I am going to copy, let's drop down into video 47. And I'm going to make clean and pop back up, and I'm going to copy video 47 to be video 49. And the reason that I'm skipping over 47 to 49, right? So we got what we want here. We got video 49. The reason I'm skipping over 48 is because that was where I tried to back out the error handling. And while I was backing out the error handling is when I realized that I never actually generated what I thought in video 47. So I went back to 47, fixed it while recording video 48, made it do what I want, or actually made it run the prompt I had tried to create. It worked, and so now we're working from that code. So anyway, video 49 is where we're starting. Now, the first thing I'm going to do in this video is I'm just going to run it. So let's start with a split right and then a split down. And then in this window, I will run the server. I need to make it first. So we make everything. We run the server, and then run the client. And then I'll re-explain it a little bit, and then we're going to go look at the code, and then I'm going to do the real thing that I intend to do in this video, which is kind of dive into epoll so that I understand it. So here I'm gonna split down again and just run another client. Okay, so the client and server, they know 3 message types. They know how to do an echo, a reverse, and a time. And what's going on here is the clients are just randomly picking one of those and sending it to the server, and then the server is handling that particular message type. Everything is working. I could do a little bit better job. Oh, that's so funny. It literally puts debug in the okay, that is so funny. Okay. Anyway, I'm going to stop these, and then we're going to take a look at the code here. Clear. Let's take a look at server.c. And what we really want is just to go look at main, take a look at how it eventually gets into its epoll event loop. So, here it's setting up everything it needs for epoll. It eventually gets into its epoll event loop. Ah, nice logic, nice tight. Everything's kind of in separate functions, easier to do. The first thing it's doing is it's just waiting for an event. That's easy enough. Then it's going to loop through all of its events. It's going to handle new connections. So if the event, why is that a new connection? So if events I data FD equals listen FD. Oh, listen FD is going to be our file descriptor up here. That is the one that just listens for new connections. So new connections only come on listen FD. And so if it's on that particular file handle, then go off and handle a new connection. We'll take a look at that in a second. Otherwise, it's going to be some kind of read, error, close kind of event. Okay, handle new connection. So what do we got here? Not a very big, not a particularly large function. We come in, we do some asserts to make sure that we're getting some valid pieces. That was at one point when I was trying to handle the error. I told the prompt to add extra asserts in there. This is all pretty straightforward. So we're handling a new connection on a particular file descriptor. We set it to non-blocking, and then we add the client file descriptor to the event data file descriptor field. If epoll CTL epoll file descriptor, if epoll CTL. Okay, so we're just error handling that. So we're adding. Okay, so now we've updated the data. We're going to pass that data to epoll to update its arrays, and we're handling the error if that happens. Client IP, INET enters string length, IP, blah, blah, blah. And here we're just getting INET at the end top. Oh, we're just doing this to client IP. We're just doing this to what is this line doing? INET and top. AF INET. Client address. Adder, client IP, INET. Okay, so I don't... why is this happening at the end of... This function converts the network address structure source into a character string, but... oh, now I understand. We're saying, hey, let's allocate some space here for the client IP, and then let's turn the thing into an actual string of a client IP, and then use it. And the client FD is actually from up here. Okay, so that makes sense. So I don't see anything in handle incoming connection that I don't understand. So let's go back up to main, and in the loop, the other side of it is handle client event. Handle client event. Okay, so here is again, it's doing some asserts. We're grabbing, just getting a convenience variable with the event with the event file descriptor. We check, okay, so now this is, ironically, this is the same code that I thought was a problem before. And maybe we didn't actually make any change here. We'll kind of parse through this. Check for hang up or error. So we check for hang up or error. If they hung up, see now the problem, the way I read it before, is if they hang up, there can still be data to read. And I'm of mixed feelings now about this. Okay, so if we walk through the logic, let's say that there was a hang up. All we do is we output, hey, we hung up, and then we return. I'm of mixed feelings because they could have sent us a valid message and a hang up all at the same, at least as far as I understand. They could have sent us a valid message and a hang up, and we hadn't finished reading the data yet, and we got the hang up first, so we disconnect. And then so we wouldn't process the valid message, that last valid message that we got. But it would never know, the client would never know whether we processed it or not because they've already hung up and gone away. So why bother hard? Why bother to try hard to handle that last event? They don't know whether we got it or not or anything. They hung up. And so while it's possible to do that, the more I think about it, I just don't think that it matters. And this clearly simplifies the code to say, oh, they hung up, goodbye. So what we do here, though, is we, on a hang up or an error, we log it, we disconnect, and we return. End of sentence. Okay, so let's go look at disconnect. Okay, it's right here. So what we do is some asserts. On disconnect, we say, okay, so this is just bothering me. This puts debug is going to just become debug : that is just too much for me. So disconnect. All we do is we say, hey, we're going to disconnect. We actually remove that epoll file descriptor, that client file descriptor null. So we just remove that from the epoll, and then we close the client file descriptor. Pretty straightforward. Nothing crazy. So what we've done, hang up or error, we disconnect, clean up our side. Checking for incoming data. If events and epoll. So here we're basically saying, hey, if these are man, I've been a lot away from C for a long time. I actually already know the answer. It is a bitwise operation. So what we're doing here is we're just looking at a mask to see whether it was this or not. And so I guess does that mean that I was just having a misunderstanding that an event can both be, it can have the epoll in, and so we are handling it. We always were handling it, even in the old code where I mistook it. Because here it's going to do the hang up, but it's still going to try and do the read if there was also a read there. Makes sense. Okay, So here it's looking if there's data in. It says, hey, we do have some data in. We're going to whenever we see that there's some data to read, we're first going to say, hey, let's read the message header, read full client head. Yep. So we're reading the header, and if bytes read. So in this case, if we read the bytes of the header and everything worked out, if it didn't work out, we go back and disconnect. Makes sense. Convert the network byte order. Makes sense. Can't, and we don't try to use it, obviously, before we get the network byte order right. And we output to received header. And then it describes the header. And then it says, if the length is greater than 0. So yeah, in theory, we should be able to have header-only messages. But what we do is if the length is 0, if it's greater than 0, we malloc that space. If the malloc succeeds, that's what the test there, we go ahead and read full. Is read full, well, is read full a function that we have defined? I think it is. And it looks like read full is returning like yeah. Okay, so it's assign size t, helper to read exactly count bytes from the file descriptor, returns bytes read 0 on end of file or -1 on error. Okay, so it's ensuring that it won't read more than through to the end of the body. Whatever that work is required to do. We'll come look at it in a bit. Okay, so let's go back to main. We want to be in handle client. That's where we want to be. Okay, so we read the header. We read the body actually because, oh no, if there's a header, right? That's what we're doing here. We go ahead and allocate the body. We read the body. If we manage to read all of that, we go ahead and process the message. After we process the message, we free the body. Header is never allocated. It's just on the stack. So we don't have to free it. And we process the message. So if we go look at process, oh, it's right here, process message. Some asserts, yeah, whatever, they're message headers. Okay, so basically we just look at the header type, we do a case statement, if the type, right? I need to set up a key binding to strip out empty lines. So we can look at all three. We just print an error if it's some unknown type. What I would want it to do actually though is, oh, it always would, right? Because we always, even if we don't know the message type, we always read the body, so that's good. A function to reverse a string. We already seen this. Read exactly. Helper to send exactly bytes. Actually, this is pretty clean kind of like it. I mean, I'm not complaining anyway. Okay, so taking a look at total read. Wow. Okay, so is read bytes. If byte read 0. If bytes read's less than 0, error. Otherwise, total plus bytes read. Okay, so when we do the read, that's where the magic is happening here. So the parameters to read are the buffer and then the size of the buffer. And so we're keeping track of how much has been read so far so that it's advancing that pointer. And then we're keeping track of the remaining space that you can read there. And you stay in a loop of total read until you get to some count. And the count comes in, so we just can't read any more than that. I want to go back up and look at read full, where read full is called. So we use it for the message header. And so basically, yeah, it says, hey, read some stuff, but no more than what's from the message header. But what I'm wondering is, where's the next one? Once it starts reading from there, and there's nothing more to read, and you didn't get the full message, what happens? And does it get stuck processing that, waiting for the full message? It's probably not too big of a deal, because obviously the client's never not sending the full message. Again, here we go to read the body, and it never really, here it's not doing anything. Like this code seems to me, given that this is single threaded, it never gave control back while trying to read. So let's go look at read full again. Here it's trying to read. If the bytes for read were 0, return total read. Return total read. So it's giving me if total read was greater than 0, and then give it total read. Otherwise, give it return 0. So we just return. If we get to a point where we can't read anymore, we just return. Okay, so I do need to understand this better, right? Because if bytes read, I mean, it feels to me like we're stuck in a loop, and we error out if we ever, so like if the full message just didn't become available, we would error out, I think. But what if these message sizes were really large, and it was taking a long time for this message to come? It seems to me like this code, well, so I need to understand non-blocking reads better. Presumably it's only going to return what's available, and that might be 0. And in that case, it seems like we would just fall through, right? We would do full read full. We would have returned. We wouldn't have the. I'm guessing I'm interpreting this wrong. I'm guessing that this only returns once it's read the full message. But But what if the full message isn't read? We get the 0, we return. 0 means clean disconnect, -1 means error. It doesn't seem to me like there's any space in here to like, oh, I read half a message, but now there's no data yet again, and I'm waiting. Seems to me to be the thing that's missing. And I guess I'm just going to have to add that to the list of things to investigate in this code. But I think I do have to, I don't dislike the way it's laid out. It's easy enough for me to learn from. I think I need to do a series of kind of question answer sessions here with the internet to figure out if like this non-blocking read thing is a problem. And then also, crap, I'm going to write this down. I'm going to say it seems like the function full read could return without having read a full message if oh no, I'll bet you I'm interpreting that wrong. It seems like full read is using a blocking read. What happens if full read doesn't get a full message? So I can figure this out, right? I can do a test where I just randomly decide to add an extra 10 bytes to the length, but those bytes never ever get delivered, right? And what I would probably want to do before I do that is I want to make sure that the client is kind of blocking in lockstep. It's not going to send a new message until receiving the response from the old message. And that should elicit whether this problem exists in the code or not. That plus some time spent probably having a conversation with Gemini about this topic is probably what I need to do next. And I go and lean back, and you guys probably, I get all quiet then probably. Anyway, I think I'm going to wrap up here. I think I understand what it is I need to do next, which is just learn more about how these blocking, non-blocking reads work. That's the only bit of the logic that seems unclear to me. So thanks for watching. See you guys next time.